Good morning. Thanks very much for joining us. We really appreciate your time today. I know you're very busy, so it's good of you to join us and take time out of your day to come along to our webinar. I'm Craig. I'm one of CASA's aviation safety advisors based in Perth. I've got a pilot background, and one of our jobs is to do presentations like this, chat to your good selves and get your thoughts on how the safety situation is going out there, and perhaps pass on some tips on how you can improve your safety performance. We're hoping to have a guest speaker today join me, Dougal McQueen. He's the head of operations at Goldfields Air Services in Kalgoorlie. He's having a bit of a technical issue at the moment and hasn't quite got onto line yet, but he'll probably join us later on in the presentation. So why do we do these webinars? Why do we do our in-person seminars when we run those as well? Well, we know that as pilots, our skills are a little bit perishable. If we don't keep on top of things, if we don't keep reminding ourselves of some of the risks that we face as aviators, some of the mitigation strategies we use to get around those risks, then things can start to go wrong. And we see that reflected in the accident statistics. So with today's webinar, I don't expect that I'm going to be teaching you anything new. But what I do hope to do is just give you the opportunity to pause your flying, reflect on how you're doing things, and just reconsider some of those risks that we face and how we're mitigating those risks. So a win for me would be that if at the end of this webinar you walk away with maybe one or two things in your mind you think, yeah, maybe that's something I haven't been given due attention to, or I've let slip a bit and I could concentrate more on. So if we can do that, that'd be fantastic. The webinars aren't as interactive as our in-person seminars. If you've been to one of those, obviously we love to hear your thoughts, get your experiences and get lots of questions and the like. But that is a little bit hard to do on the webinar format. You'll notice that we've muted your cameras and your microphones. That helps us with bandwidth, helps things run a bit more smoothly. But what you can do is if you sort of look up the top of your screen there, you'll see the chat function. So it's a little sort of dialog box with chat written underneath it. If you open up that, it'll appear on the right-hand side of your screen. And as we go through the presentation, you can actually type in any questions you might have or any comments you might have. So we'll go through those at the end of the presentation with the time that we have available. The good thing about the webinars, even though a little bit more clunky, is that you get to join us from wherever you can, and hopefully you've found somewhere nice and comfortable to join us, got a hot coffee or tea, and you can settle in for the next 45 minutes and hopefully get a few things out of our webinar. The webinar is recorded, so if for any reason you have to step out or whatever, no problem at all. We record the webinar, and what we do then is put it on the CASA YouTube page, which I've no doubt is the top of your favourites list there. So your YouTube page for CASA, the recording will appear there in a couple of days, and you can watch the whole thing through if you need to. We'll also follow up with an email after the presentation, and the email will do things like answer any questions that we didn't get time to answer as part of today, and also gives you a couple of links if we've been talking about various resources and the like. If you have trouble seeing our presentation, there's a PowerPoint presentation. We often get a couple of people who can't see the slides. Unfortunately, there's not a lot we can do about that from this end. We would suggest doing things like leaving the meeting and coming back in, maybe changing your browser that you're using or something like that, which may help. But if it doesn't work, then just remember the recording's there. One of the things I'm always telling people at these seminars, pilots, is as a pilot, we should always have a plan B. We should always have a backup if things go wrong. So I'm going to practice what I preach here. I am going to have a plan B if we have any tech issues, which come along every now and then, and the presentation gets interrupted. If that happens today and we have to abandon the presentation for any reason, we'll go away and record it anyway, and then still put it on the YouTube page. So it won't be as interactive. I won't get some of your questions and the like, but you'll still be able to see the information presented. So today, what are we talking about? We're talking about stabilized approaches. That part of our flight between, getting to the airfield, that final phase where we're descending towards the runway to carry out our landing, our touch and go, or in some cases a practice, go around or missed approach. Why are we dedicating a seminar just to stabilised approaches? Well, we'll talk about the accident statistics and what we're seeing out there at the moment. We pick these safety topics based on what we're seeing in the accident data. And if you're coming along to these webinars to chat about these issues, we've partnered with Credly to get what we called digital badges. So if you stay to the end of the presentation, you're going to get a follow-up email that has one of these digital badges on it. If you haven't seen the digital badges before, basically what you can do with them, you can put them in email signature blocks, you can include them in your digital resumes, you can share them on social media, and they just show or act as an indicator of your commitment to safety, engaging in safety material, education material, and discussions. So you'll get an email with that if that's of any use to you, and I hope it is. So, stabilised approaches. What's the difference between a duck and a co-pilot? That is a really strange statement to start a safety presentation with. I'm guessing some of you out there will know why I've started with that comment. If you don't, that's okay. We're going to go through it now. That comment was recorded on a cockpit voice recorder of an Alaskan Airlines flight some 50 years ago. It was a Boeing 727 and it was approaching into an airline called Ketchikan in Alaska. And it was one of those iconic aviation accidents from the 70s and 80s that resulted in a complete rethink of how we train crews, complete rethink about crew resource management, non-technical skills like decision-making, communication, risk assessment, and the like. And the accident that resulted out of that particular flight was a runway overrun where the aircraft left the end of the runway and crashed. One person was killed, 32 people were injured. It's one of the more well-known examples of an unstabilized approach gone wrong. That was 50 years ago. Let's have a look at what the ATSB has said as late as 2019. Unstable approaches continue to be a leading contributor to approach and landing accidents and runway excursions. So what we can see is that even some 50 years after we've had accidents like this, we still see it feature in the accident statistics. And I make this comment pretty often in my seminars, is that as pilots, we aren't inventing new and crazy ways to get ourselves into trouble. If you look at the accident data coming out of the ATSB and the NTSB and the like, you'll see that we sort of repeat the same mistakes over and over. I think it was James Reason that referred to it as the awful sameness of accident types in aviation and around the world. So as pilots, if that's still happening, our job is to look at what's happening, try and understand why it still happens, and then most importantly, see what we can do with respect to our practices so that it doesn't happen to us. And that's what I want to do today. Work out why these accidents still happen, what we can do about it to prevent it happening from us, or to us, I should say. So what do I want to do to help achieve those aims? I want to look at what constitutes a stable approach. Let's understand what one is so that we know what it looks like and more importantly, what it doesn't look like. We'll have a look at the accident data, give us an idea of what's going on around the world, and look at a couple of case studies of what went wrong, including the one that I just referred to with our comment there. We don't look at the case studies to point the finger of blame at the pilot. These are people like you and I. They didn't set out to have an accident. We're really here to try and extract the lessons from those case studies. We'll talk about some risk mitigation strategies. How do we stop ourselves being involved in one of these particular types of accidents? And then we'll look at the important part that training has when we are trying to avoid the risks associated with the unstable approach. So I guess the starting point is, what is a stabilized approach? If I went all around everyone with us here today and asked what your version of a stabilized approach is, the answers might differ slightly, but I reckon the fundamental points will be the same. So a good starting point is the FAA's Airplane Flying Handbook. They put in a pretty good broad brush explanation or definition of what a stabilized approach is. And they say it's one in which the pilot establishes and maintains a constant angle glide path towards a predetermined point on the landing runway. It's based on the pilot's judgment of certain visual cues, or clues I should say, and depends on maintaining a constant final descent airspeed and configuration. constant angle glide path, predetermined point, constant airspeed, constant configuration. They're pretty standard parts of the definition. But I think as pilots, we probably, to put it into practice, need a little bit more granularity on that. We need a little bit more to hang our hats on. So if you fly for an organisation as a commercial pilot, your organisation has likely got what they consider to be stabilised approach criteria in their ops manuals. If you're a private pilot flying for recreation, you've probably got in your mind things that are a little bit more prescriptive than our general definition there. So what are some of the things? This list isn't intended to be the be-all and end-all of what a stabilised approach is, but it's typical of what most of us consider a stabilised approach to be. First of all, we need the correct glide path or approach aspect. There's no point in having the correct aim point, for example, if we've got a 30-degree approach angle to it. It's too steep, so that's dangerous. So we do need the correct glide path. Typically that sits around the sort of 3 to 5 degree glide path for most aircraft types, but depending on your aircraft type, where you're operating to, etc., that may change slightly. But certainly a good approach aspect is critical to a stabilised approach. I'd love to say that every approach I've done has been stable and perfect all the way down. Unfortunately, that's not the reality. We know that there will be slight changes as we approach. We will need to make slight adjustments and corrections to keep the approach stable. That's fine. As long as those changes are small, manageable, and you've got enough time before you get to the touchdown point to make them safely. That's the important part. So small changes are fine in heading and pitch, power, etc., so that you can maintain a correct flight path. With respect to airspeed, typically what we see there, we don't want less than VREF in most cases. That's the speed we'll get out of our flight manual for the approach configuration. And with respect to the maximum speed, that probably tends to vary a little bit more. Most people will say something like VREF plus 10 as being your max speed, but in certain circumstances that can be expanded out a bit. And of course, that'll depend on a number of factors. It'll depend on the type of aircraft you're flying, how much momentum, how large is your aircraft, and how long will it take to correct any airspeed errors? What's the runway length you're operating to, runway slope, etc., etc. So that's a pretty good rough guide, but that may need to be modified for certain circumstances. We definitely want the aircraft in the correct landing configuration. We know that any changes in configuration can change things like the pitch of the aircraft. It'll change the drag and therefore change the airspeed. Therefore, we need to change the power, which can then result in further pitch changes, etc. So the aircraft configuration is really important to get stabilized nice and early so that you can stabilize all the other factors before the touchdown. With respect to rate of descent, anything above 1,000 feet is probably not normal. If you need 1,000 feet per minute rate of descent or in excess of that, something has probably gone wrong with the approach. The accident data around CFIT accidents, controlled flight into terrain of aircraft on finals, and not just in Australia, this is around the world, shows that a lot of those accidents included a precursor factor of the aircraft having a rate of descent in excess of 1,000 feet per minute. You shouldn't need that much rate of descent, and there's dangers associated with it. When we see the CFAT accidents, we see things like people descending so fast they get distracted and don't correct in time. So we really want to have a look at the rate of descent. I'm not going to put a firm number on every aircraft, but I know the aircraft I fly, 550 to 650 feet per minute is a nice rate of descent, but anything in excess of 1,000 should be ringing our alarm bells. We also want the appropriate power set. And as I mentioned before, if we change power, we can change trim of the aircraft, etc. So hopefully we've got the power nice and stable with some small changes to adjust as required. And admin that we might have to do with respect to briefings and checklists, it's really good to get them done as early as possible so they're not distracting us on finals. Now, I would suggest one of the ones we can do, an exception there, would be our finals checks. We definitely want to make sure we do our finals checks before we touch down. In the case of a controlled aerodrome, we may not get our clearance till quite late in the approach, so we might need to do our finals checks quite late. But all the other admin, briefs, checks, etc., ideally we'll have done well before we get to somewhere like, mid-finals. So I think that's a lot of good detail about what a stabilised approach is, and that's what we should be looking for as pilots when we're on finals. If any of those things aren't there, then we really shouldn't be considering it as a stabilised approach. Let's have a look at what can happen if we get involved in a unstable approach. That picture there shows a pretty typical outcome. That's a runway overrun. If we land too fast, too long, incorrect braking technique, etc., we can end up off the end of the runway, and the consequences of that can be catastrophic. The reverse is true. We can go, we can end up before the runway, impacting terrain before the runway. We see that in a lot of CFIT accidents. We can leave the runway due to lack of control, etc. So these are the typical outcomes of an unstable approach that is not properly dealt with. The accident data is really good. It's really good to study, and it's really good to pick up clues as to how these things happen, and more importantly for us, how we can use those clues to prevent it happening to us. When we look at the unstable approach type accidents that are occurring around the world, there's 4 main precursor factors that feature in a lot of them. Let's have a look at what they are. This one, I don't think will be a surprise to you, adverse weather. If we have things like strong winds, gusty winds, any wind shear, turbulence and the like, you know what it's like coming down finals in conditions like that. The airspeed can be all over the place. The aircraft's rocking around. The attitude and aim point aren't staying stable. That can really adversely affect us. So I think that one's a pretty obvious one. ATC pressure is another one. That can be real pressure or perceived pressure. We could get a very straightforward instruction from ATC, can you make a short circuit due to following traffic, etc. Or if we operate somewhere that's really busy and we know what the ATC people have to deal with to try and coordinate that, we might feel pressure to act quicker than we normally would, get on finals quicker than we normally would, approach faster than we normally would, just to help ATC out. So that does feature quite heavily in our unstable approach type accidents. Late changes of runway, another fairly obvious one when it involves track shortening. Can you make runway X from your present position? That might put you out of your comfort zone. And commercial pressures, these are an interesting one. Commercial pressures are real, they're there. They're not good, they're not bad, they're just a reality of aviation. Our job as pilots is to make, and operators is to make sure that we get the balance right between the commercial implications and the safety implications. That's where the critical point is. So they can be real or they can be perceived. And I don't think you need to be operating for a commercial organisation to have commercial pressures. If I'm flying privately and I have to do a go round at another circuit, that's going to cost me money. But that's a reality of aviation. Again, not a good thing, not a bad thing. It's a reality. We just need to make sure that balance between the commercial factors and the safety factors is appropriate. So those 4 factors are what we saw in a lot of the unstable approach type accidents. Does it mean if those factors are present, we will have an unstable approach? No, it doesn't. We might manage them properly and be able to execute the approach with no problems. Does it mean if they're not there, we won't have an unstable approach? Again, no. There's a lot of reasons we could have an unstable approach. One of our passengers could be distracting us. Everything could, or an emergency or something like that. So, but they are common ones. So it's good for us to be able to look out for those in our own flying and use them as a little bit of a, sort of warning sign. Oh yeah, I remember that one. That's a setup or potential setup. I need to be careful here and be conservative. So we'll look at a couple of case studies now about unstable approaches going wrong, and keep in mind those precursor factors and decide for yourself if you think they are an influencing factor on these particular ones. So the first one I want to talk about is the one where our quote came from. What's the difference between a co-pilot and a duck? This was Alaskan Airlines Flight 60, as I mentioned, in 1976, 727. Looking at that photo, I think it's miraculous that only 1 person was killed and 32 people injured. That is the result of an unstable approach that wasn't properly handled, and they've gone off the end of the runway. Initially, the aircraft started on an ILS approach, instrument landing system. So basically one of those approaches, if you're not aware, you get azimuth and glide slope indication in your aircraft, and you can fly a nice sort of 3-degree type approach down to the runway in bad conditions. At 4,000 feet, this crew broke visual from cloud, so they discontinued the ILS approach, which was probably not a good idea in retrospect. It would have helped them with their approach parameters, and they continued on a visual approach from 4,000 feet. In this case, they had three knots of tailwind. So if we think back to our precursor factors, adverse wind, etc., 3 knots of tailwind, look, it's not great. It's not unmanageable, but it certainly didn't help the situation. Now, with accidents, they're complex things. There's a whole range of factors that lead up to an accident. I can't just say that what the crew did with respect to communication, etc., caused this accident. There's a whole bunch of different factors. We're just going to focus on the unstabilized approach factors. And what I thought I'd do, instead of going through chronological order what happened over the period of the approach, I thought I'd just look at each crew member individually and what they said as recorded on the cockpit voice recorder. And as we go through what they said as this approach progresses and deteriorates, I'll let you decide if you think this person or this particular crew member recognised that the approach wasn't going well and took appropriate action to overcome that. Let's have a look at the first officer first. So the first officer, he was the pilot monitoring, the captain is flying, and sitting between the two pilots and slightly behind him is the flight engineer. So here's some of the stuff that the cockpit voice recorder recorded for the first officer, what he was saying. Want me to fly today? Very diplomatic. What's the glide slope there, John? John being the captain's name. This is a little faster than you normally fly this, John. Seems like there's a bit of wind up here, John. Tailwind up here, John. John, you're just a little below the MDA here. This is a little too high. I think already you probably agree with me that this crew member clearly recognises that the approach is not going the way it should. The language so far has been pretty diplomatic. He's trying to key the captain in that he's not happy. No direct instruction on what he thinks the captain should do as a result, but remember this is back in the 70s, before that cockpit authority gradient had been properly understood and managed and trained. But he's certainly not happy with what's going on. And as the approach continues and deteriorates more, let's see how his language changes and becomes a bit more direct. You really look awfully high. He continues, as the approach deteriorates further, John, you're really high. You're gonna need 40 on the flaps here to get this thing down. I don't think you're gonna make it, John, if you don't get this sucker on the ground. Things are getting pretty desperate now. I don't think you're gonna make it. I don't think you're going to make it. When they reach the point of no return, they're now on the runway, landed long, high speed. They have no or insufficient runway to either stop in time or to get the power up and get airborne again. They effectively have no good options. The first officer says, it isn't going to stop, John. We're not going to make it, John. Great, John. I told you, geez. So we can see from the first officer's language that it was pretty evident from early on in this approach that things weren't going well. Did he recognise the approach was unstable? Obviously he did. Did he take action to try and correct it? Well, that's a hard one to answer given the time frame, how long ago it was. I don't know what this airline's SOPs these days. They have very clear terminology that the first officer can use to prompt the captain to take action. But he certainly tried his best, I think. And for those watching that fly light aircraft, please don't think that unstable approaches are only a problem for big aircraft like this. It's anything that flies, basically, can be led into an adverse situation with an unstable approach. So that's what the first officer was saying. Let's have a look at what the captain did in response to what the first officer was saying. So as the approach progressed, as the first officer was making his, the fact he wasn't happy increasingly obvious, sometimes the captain just didn't respond to what the first officer was saying. Other things recorded on the CVR, well, we know where we are, we'll be all right. Oh yeah, but it's nice and smooth. We're going to get in right on time, maybe a little ahead of time. We got it made. Yeah, we're saving gas. Help us get in a couple of minutes early too. This is a fairly common human trait where we don't like to be in bad situations, so we almost try and talk ourselves out of it. We almost ignore where we are and try and convince ourselves we're in a better situation than we are. As pilots, we can't do that. We need to acknowledge everything that's happening in front of us and then deal with it appropriately. So this captain at this stage is not listening to or not acknowledging the concerns of the first officer and really try and talk his way out of it. Yeah, we'll take care of it here, but at some point the pilot or the captain also realizes he doesn't have any good options. They're on the runway too fast, and he says, we're going around, oh damn. So way too late, he's elected to try and do a go around, insufficient runway to do that, and they run off the end of the runway. Had that decision been made some minutes before now, we wouldn't be talking about this incident. This is a critical point in this accident for us as pilots. Let's put ourselves in the captain's position. He's a pilot just like you and I. He didn't set out to have an accident. If he'd known it was going to be an accident, he would have acted. So we need to think what factors would maybe make us fail to act like this pilot. And as human beings, we're complex critters. There's a whole range of reasons why that might be the case. It could be ego. We simply don't want to admit to our fellow crew members or people, our passengers, that we've done a bad approach, we've messed it up, and we need to do a go around. Could be a medical episode. Maybe I'm fatigued. Maybe I've got something else on my mind that's not related to the flying. In this case, I believe there was some potential medical considerations that may have affected the captain's decision making. And I can't remember the exact condition that it related to, but anyway, there could be a whole range of things, prescription medication, et cetera, et cetera. It could be just incompetence or lack of recency. Maybe we haven't been flying for a while, the conditions aren't great, we haven't really thought too much about our personal limitations, and we've got airborne conditions that are a little bit beyond us, given our lack of recency. And it could be things like groupthink. Now, groupthink's a funny one to mention here because so far we've only heard from one other crew member who wasn't reinforcing the captain's decision to continue the approach. But what we need to do here is look at what the flight engineer was saying. So the flight engineer is listening to the first officer, start to raise his concerns with increasing desperation about the approach. And this is what the flight engineer was recorded as saying. Don't you worry, he's talking to the first officer, the Fox is going to have it wide. So clearly complete faith in the captain and reinforcing to the captain that, whatever you're doing is obviously good and I've got complete confidence in you. It's a little bit later in the approach when the co-pilot or the first officer continues to raise his concerns that comment comes up. John, what's the difference between a duck and a co-pilot? The captain asked, yeah, what? And the first flight engineer responds, a duck can fly. So in the middle of this situation with a unstable approach that's deteriorating, not only is the flight engineer not listening to the co-pilot, he's actively denigrating him in the cockpit. So again, an iconic example of crew resource management gone wrong, communication gone wrong, etc. And the flight engineer ends up in the same position as all of them, of course. And when it's too late, he's just saying, get it down, John. So in looking at those three particular crew members, again, I think we can all recognize who worked out the approach wasn't going well and whether or not the correct action was taken. Back to our four precursor factors, were they a factor in this particular instance? Adverse weather? I think you could say, yeah, there. The 3 knots of tailwind isn't great, but certainly not unmanageable. We certainly could complete a safe approach if it's acknowledged that there's a bit of tailwind and is correctly monitored. ATC pressure, late change of runway, don't feature in this accident. Commercial pressures, I think they're always there regardless to a certain extent. So we'll say they did feature, but they didn't appear to be an overriding factor. So a lot of this one came down to recognition and decision making. And as I mentioned, it's not just big aircraft that can suffer from the adverse effects of an unstable approach. It's anything that flies. In this case, we'll have a look at a 172. This one occurred only last year, less than 12 months ago in Florida. And in this case, it's an instructor and a student. So this is another good one for the instructors of you here today to have a look at as well. So this is a pilot under instruction, and they're doing a forced landing, sort of a semicircular forced landing from base to touchdown. During the approach, the students flying, the instructor notes that there's low airspeed and that the flight path was low. If we think back to the definition of a stabilised approach, we can see that two of the big ones are not present here. This is not a stable approach, and the instructor has recognised that it's not a stable approach. But what does he do about it? Well, in the accident report, he said he decided not to intervene because the purpose of the flight was to evaluate the students' piloting skills. We could do a whole other seminar on that decision, and you know, we do that. In fact, in our flight instructor seminars, we talk about the correct point to step in if your student pilot's you know, making a mistake. Where does the learning finish and it just start to get dangerous, etc., etc. But in this case, I think it's safe to say that although the pilot was able to identify the fact that it wasn't a stable approach, the response was insufficient. The aircraft landed firmly at the threshold with the student still at the controls, and the horizontal stabiliser hit a runway threshold light. I'll just show you a couple of photos of the damage. Now, personally, I think those two pilots got out of that pretty lightly. They're pretty lucky. That could have ended much worse than it did. It had the situation deteriorated any further than it already had. So again, it's not just big aircraft. The stabilised approach is important for everything that flies, and we need to understand for our particular aircraft and operation what constitutes a stabilised approach. So it was at this point I was going to introduce Dougal. I'm not sure if he's online yet. We'll just, Courtney, if you could just let us know if Dougal's here as yet.
Sadly not, Craig.
No problem. Plan B. Got my plan B in place. What we'll do is we'll record a few comments from Dougal when he's able to join us, and we'll hopefully include them on the recording. Dougal's got a lot of experience in general aviation operations, aerial mustering, fixed wing. He's been 15 years of the head of operations of Goldfield Air Services. They run Super King Airs, 172s in their training environment. So he's got a lot of good knowledge to pass on to you as well. So hopefully we'll get a few comments from Dougal as well. One thing he did highlight with respect to the VREF speeds that we talked about as a stabilised approach having a minimum speed of VREF, he made a good point saying, well, actually in some cases you might want to bump that up, particularly for things like light twins. Light twins have some fairly adverse VMCA considerations if we're on a single engine, and if we put the power up too much, for those of you that don't fly twins, when we've only got one engine, we get this quite significant yawing motion, and sometimes the vertical stabilizer isn't strong enough to stop it. The aircraft effectively just spins, auto-rotates. To stop that happening, you sometimes need to carry extra speed down finals above what you call the blue line speed in case you need to do a one engine go round or you have an engine failure on a go round. So if you are flying twins, when it comes to the VREF or your minimum speed on finals, make sure you throw that into your considerations. We'll continue on and we'll talk about mitigation strategies. So how do we prevent unstable approach accidents? That's what we want to do here. So there's a few ways we can think about this. If we want to avoid unstable approach accidents, we can avoid unstable approaches. Don't go near them, don't let them happen. That's great, fantastic, but we all know it doesn't matter. Despite our best efforts, everything going fine, we can still, for a whole bunch of reasons, end up in an unstable approach. So yes, we will try and avoid them, but we've got to be ready for when they inevitably happen anyway. So if that's the case, we need to be able to recognise and acknowledge that the unstable approach is there. Recognise and acknowledge. Make sure we admit to ourselves, I think I've got this wrong on this occasion. I need to take action. So as we saw in that second case study, recognising the unstable approach wasn't a problem, but acting was the problem. So once we recognise it, acknowledge it, we have to act appropriately. So let's sort of break each of those ones down. If we want to avoid an unstable approach, well, of course, we can know what one is, so we can basically set things up nicely. But those four precursor factors that we talked about are a good starting point. We know that if we see those, the chances of being in an unstable approach increase a little bit. So if we avoid the precursor factors, that will help us avoid unstable approaches. Of course, we're not going to always be able to avoid them, but at least we know we can be pre-warned or pre-armed. So if we can avoid adverse weather, Perhaps we can not fly when the weather's not, the forecast isn't good. Perhaps we can hold if we have sufficient fuel until the weather passes, or divert if we have sufficient fuel. Maybe pick a better runway that's more favorable, etc. We can avoid ATC pressures. ATC, I know a lot of ATC people, and there is absolutely no way that they expect us to take ourselves out of our comfort zone to try and fit in and make them happy or make their job easier. They want us to fly safely. If that involves you saying, actually, I can't accept that clearance, can I get some more track miles? Or I'm going to need to depart that uncontrolled aerodrome circuit so I can get better set up for the runway that everyone else is using that I wasn't aware of. That's what we need to do. If there's a late change of runway, don't accept it if it's going to rush you too much. Or even if you accept it and decide, actually, no, I thought I could do that, but I can't, let's do a go around. And the commercial pressures, again, we just make sure we're getting the balance right. And remember, there's that old adage, what is it? If you think safety is expensive, try having an accident. We modified that the other day when I was chatting with Dougal. If you think a go around's expensive, try overrunning the runway. So make sure that balance is correct. So if we can avoid the precursor factors, if we know what a stabilized approach is, hopefully we can avoid having a stabilized approach. An unstable approach, I should say. But you and I both know that that's not always going to be the case. A whole bunch of things can line up and we can find ourselves in an unstable approach. So to recognize it and acknowledge it, obviously we need to know what constitutes a stabilized approach. We've talked about that. And there's this technique of establishing gates. And if you don't do this already, I highly recommend this one. So what we do is we have particular points on finals, or gates as we call them, where we ask ourselves the question, is the approach stable? And at various gates, your options change. If the gate is way back on finals, early finals, your options, if the approach isn't stable, would be to ask yourself, is it correctable? Is it safely correctable from here? Yes, I'm going to correct it. Or can I do a go round? That option is there as well. As we get later in the approach, then correcting might not be an option. It's too late. Your only option might be to commence a go round, or if you're on an instrument approach, a missed approach. So where those gates are is up to you. It's up to your aircraft type, how much momentum it carries, how much runway you've got, etc. Typically 500 foot is a good one for most light aircraft. As you're on finals at 500 feet, we get this internal monologue going that I've got on point number 3 there, and actually ask yourself, do it out loud if you want to, is this a stabilized approach? And it's a yes/no answer. Yes, continue. No, I correct it or I go around. So if we get into that habit of doing that on every approach, then it's a really good indicator and prevention method for us to continue with an approach that's not desirable, that's not stable. So know your stabilized approach criteria. Establish gates. Where they are is up to you. Talk to other pilots and see what they use. I like a 500 foot one when I'm flying smaller aircraft, 1,000 foot if it's bigger aircraft with a little bit more momentum. And practice that internal monologue. Actually ask yourself the question, stabilized approach, yes or no? That will help us recognize and acknowledge. Then, once we've acknowledged it, and it is an unstable approach, we have to act. So if it's practical to fix it, and we're not too far or too late on finals, go ahead and fix it. If it's not practical to fix it, or the error is just too gross, go around if you're doing a visual approach, missed approach if you're doing an instrument approach. And think back to our 2 case studies. If that decision had been made, and it's quite a simple decision, we wouldn't have been talking about those 2 incidents. Seems simple, and I'm sure you've heard it before, but again, the accident statistics show that it's still happening, and that's why we're talking about it. With the emergency, the point number 3 there, what I'm getting at there, emergency situations may require less than an ideal approach. Let me give an example. You've got a wing fire. You're on finals with a wing fire. You get to your 500 foot gate and you notice the approach is slightly high, probably a little bit more than you're comfortable with for normal approaches, and you'd normally do a go round. Well, you know what, in that case, the go round probably carries more risk than landing slightly long and fast and potentially having a runway overrun. So rarely in aviation are things black and white. There may be the extreme cases where persisting with an unstable approach might be a better option. It's going to be rare, but the possibility is there. So make sure you throw that into your decision making. Training is really important, and this is training if you're a part of a commercial operation that has a check and training system, if you're a part of an aero club where you can get to fly with flight instructors quite often, or whether you're just a private pilot and you want to engage the services of a flight instructor more often than your 2-yearly flight review. Training is what is going to make us proficient at this sort of stuff and minimize the chances of us having this one of these events. So a couple of points in training: if it's part of a commercial operation, management support is critical. That's true of all safety facets. If the management's not behind the safety program, it's not going to happen. So if you are a manager, have joined us today, remember that. I'm sure you knew that already, but what you say, what you do, how you lead by example is going to set the standard for your organization. If you say one thing but do another when you find yourself on an unstable approach, that's what your pilots are going to see and probably emulate. Normalize go-rounds. They are a normal part of aviation. A go-round is not an admission of failure that I've got the approach wrong. We know we're going to get approaches wrong. It is going to happen. Nobody joining us today is immune from a bad approach. If you think you are, let's have a chat. So normalize go-rounds and every now and then practice them. Even if the approach is good, practice a go-round so it's not a unfamiliar thing for you. If you don't already, establish those gates and establish your approach, stable approach criteria. Make sure you refer to them. Part of an organisation, educate and test your crew's knowledge regularly. That helps keep it at front of mind. And obviously lead by example, clear demonstrations of the expectation of your crews if they find themselves in an unstable approach situation. And be consistent. As I said, if you say one thing and do another, that's an inconsistent message to your crews. If you fly by yourself, be consistent with always checking at the gates, always looking at their stabilized approach criteria, and always doing a go around if you're not happy that you can correct it in time. Be consistent, especially when you're fatigued or everything's not working on that day. You might have an emergency or a difficult passenger. These are when we might get caught out. And if you are part of an organisation that has a safety management system, use the mechanisms within that safety management system to input any incidents that happen, and then use that safety promotion and compliance type matrix to work out how you're going to deal with it, make sure it doesn't happen again. So a couple of ATSB comments to finish off here. These are really important for us. They sort of sum up what we're talking about. A go-round to recover from an unstable landing, so now we're already in the flare like the 727 and realising, well, this isn't good. It's more dynamic and presents a greater challenge than a go-round from final approach. If we make the decision early while we've got a bit of momentum, bit of airspeed, bit of height, it's going to be less dangerous than if we wait till we're effectively too late or in the flare. Although the procedure for go-rounds generally applies to both scenarios, it requires careful application when implemented in the landing phase. Make the decision to go around early, it'll be much safer. Hey, we might have to go around late in the flare for a variety of reasons. Doesn't mean we shouldn't, but we try and avoid that if we can get a chance to make that decision earlier. And an important point for anyone who's joining us today who flies the Cirrus SR22, the Mooney, or any aircraft that has those sort of adverse torque effects when we apply full power at low airspeeds. The ATSB says pilots of single-engine aircraft with relatively high power engines, such as the Cirrus, I'd include the Mooney in that as well, need to be aware of the potential for significant torque effects, loss of control associated with high engine power, low airspeed, high pitch attitude. So thanks for your time, ladies and gentlemen. I hope you certainly got something out of that. Unstable approach accidents, they're not new, but they do persist. So I hope today, as I said, you'll walk away with maybe one or two things that you think, yeah, there's something I can concentrate on a little bit more in future, or that was a good reminder to me about why we do that particular thing, and you can be on your guard a little bit more for things, the risks associated with unstable approaches. So I've talked a little bit too long there, and we're about to go over time. I just got a couple of quick notices for you. Submit your close calls if you can. These are your experiences that you may have had. They're de-identified, but they're really valuable learning. Each and every one of us here today will have a close call, particularly after controlled aerodromes and operations, non-controlled aerodromes, weather and forecasting, flight planning, aviation maintenance. If something in that sphere's happened to you, we'd love to hear it. Another notice here, ADS-B. This is really coming along in leaps and bounds and really is the way of the future for us in aviation and separating ourselves. We know it's compulsory for IFR aircraft at the moment in most circumstances, and eventually we're all going to enjoy the benefits of ADS-B. So it's important we understand what it is and the best options for us now. And in fact, it's so important, we consider it, and air services consider it so important, the Australian government's rebate on ADS-B fitment to your aircraft has been extended to 2027. So you can actually apply for a grant of up to 50% of the cost to purchase and install ADS-B. Now, if you want to decide what's the best ADS-B for you, we've produced this card that you can see on the screen, and it gives you all the different sorts of ADS-B fitted equipment and what it can do for you. So I strongly recommend that resource for you if you want to get your head around that a little bit more. Flight Safety Magazine, you might have a wedding anniversary coming up, a special birthday. Imagine how thrilled they would be if you give them the Flight Safety Magazine subscription, especially when they hear you got 50% discount, and there's a code there, FSA 502026. If you go online and order that subscription, you can get 50% off the subscription fees for the magazine. Awesome magazine, everything in there, something for everyone, really, really good. Thank you, ladies and gentlemen. I did talk a bit too long there. I apologise for that. I'm just going to go really quickly through the questions for those, if anyone's still there, and I'll just see if I can address any of those questions. So I'm just going to go back through the list. Thanks for your comments. Are there such things as mobile portal ADS-B? Do you have to be an aircraft owner to purchase one with government rebate, or can pilots buy them as individuals? That's a good question. I'm pretty sure it's linked to an aircraft, but I'm sure if you go to that web page, it'll be able to give you a few more details, and I'm happy for any of my CASA colleagues who may have more to share on that to jump in. And that looks like the only question there for the moment. So thanks, Jeff. Feel free to email us when you get the post presentation email if you need more details, and we can chat about that with you. Thanks, ladies and gentlemen. Enjoy the rest of your day, and thanks very much for joining us.